Hello, everybody. Today, I will try to explain how you can apply multilinear regression to your data. And in my previous videos, I explained how you can apply or how you can add the solver and data analysis tools in your Excel. And now we will need the solver tool to apply multilinear regression. This is multilinear regression. And we have data from a catchment. It involves rainfall, temperature, and stream flow data. The last column, the dependent variable, and these two first, rainfall and temperature, are the independent variables. So we want to find the relationship between them, nonlinear relationship using the nonlinear regression. And now we can write our nonlinear regression equation. And here, these are the coefficients. Our coefficients, we will need this. And these are the initial values of the coefficient. First, we need to add some initial or arbitrary values to them to calculate the nonlinear regression, but not optimized yet. Here, first, we multiply these coefficients, but we need to keep constant these coefficients by adding dollar sign and then multiply by rainfall data and plus and another coefficient, again keeping this constant by adding dollar function, dollar sign, and multiply by temperature, and then we can add here the nonlinearity by using power sign for the Excel. So here power sign is this, and we can write here another coefficients. This is G2 column, and here also we need to make constant, and then plus this is our bias coefficients. Now nonlinear regression equation is okay, and we ticked here, and then we can tick the corner of the cell, then it can calculate for the other data also. And now we need to calculate square error. Why? We will calculate average square error or mean square error. Then we will optimize this or minimize this square error to find the optimal nonlinear equation or optimal coefficients of the nonlinear regression. So we can write, let's calculate the square error by subtracting the nonlinear equation results from the measured values. And by getting square of this error, now this is the square error for the first data set, and then double click the corner of the cell, and we calculated all square error. Then we can calculate the mean square error by getting simply getting average of this column. So this is our mean square error. Then we can use the solver tool now. Under data, we click solver. And this editor, we will add which cell we want to minimize or maximize. So we select mean square error. Okay, and here you see you can also make maximum or minimum or some specific value. You can approximate some specific value for this cell. This can be mean square error or any other thing. You can set the objective function here. And which variable or which cells do you want to change or optimize? These are our constants. We want to change these in optimization problem. So first, I prefer to use default values. Actually, this is default method, also generalized reduced gradient nonlinear optimization method. I will use this. Another alternatives, simple linear programming and evolutionary. This is also genetic algorithm. Then you can check the options parts, and you can change some values here. So I prefer the use of default values. Actually, I will show it. Then you can also check the other options. And we will tick solve now. Yeah, here you see it was converged. So tick OK. You see that mean square error minimized here. And then we can check the coefficients. You see coefficients were changed. These are the optimized coefficients. Then we can check the similarity, or check how our model approximates the measured values by drawing. So under insert, we can add scatter plot. This is scatter plot. We can carry these to upper side. Yeah, this is scatter plot. And in this scatter plot, you see these are measured values, and this is the stream flow or observed values, and these are the relation. And then we can add trend line by taking right click using mouse, and then here in the open box we can select display equation and display R square. Then we can see the relation how it approximates. So you see these are the line equation, and this is the R square value. You see the successful application of nonlinear regression by using generalized reduced gradient optimization. And then you can also apply these to your data. Thanks for your patience.